Hi there, welcome to my channel. In this video, I'm going to discuss about the trie data structure implementation. Let's look at the problem description. We need to implement the trie class, which has 4 methods. The first one is the constructor method that initializes the trie data structure. The second method is to insert a word into the trie data structure. And the third method is search the word in a trie data structure. If the word exists, we have to return true, otherwise we have to return false. The fourth method is starts with method. This will return true if there is any word which has the given prefix. Otherwise, we have to return false. Let's take a look at the example 1. So we are given a series of operations and the corresponding input. The first operation is trie, which initializes the trie data structure. And the second operation is insert the word apple. So the output is null. The third operation is search the word apple. Because we already added apple in the trie, this operation will return true. The third operation is search the word app. Because there is no word app inserted in the trie data structure, we have to return false. Even though this word has a prefix app, when we include a word in a trie data structure, at the end of each valid word, the last node of this word should be marked as the end of word. The next operation is starts with operation that will look for the word with prefix app. So in this case, we have a word apple that has the prefix app, so it returns true. The next operation is insert app, and that returns null. The last operation is look for the word app. Because we added the app recently, this operation will return true. The constraints for this problem are the length of the word and the prefix are ranging from 1 to 2000, and the word and the prefix consist only of lowercase English letters. At most 30,000 calls will be made to insert, search, and starts with methods. Let's see how to implement the trie data structure. So we are given a list of operations and the corresponding input, and this is an expected output. Okay. So the trie is a specialized data structure which is used for storing the string data from a set of strings. This trie data structure differs from a regular search trees. In the case of regular binary search trees, we see the data is actually stored in the node. But in this case, in the trie data structure, each node's positions in the tree determines the key value associated with that node. And each node has a pointer to 0 to n number of children. Basically, this is kind of n-ary tree. Okay. And to store the child pointers, you can use either a list or map. As per the problem description, we have the strings contain only the lowercase letters. So the possible values are from smaller a to z, totally 26 characters. Basically, we need to store 26 pointers in each node. So if we use a list, each node will have pointers to 26 children. Whether there is a data present in a tree or not, each node will have a 26 pointers. For example, here the root node has pointers to 26 children, and this node B has a pointer to 26 children, and this node has a pointer to 26 children. But so far we have only inserted 2 words. Bat, the pointer to a child node that represents the key B, is located at index 1. Basically the ordinal number of that character in the valid characters. Okay. The pointer to this node present at index 0 in the child pointer list. But these pointers are all empty and the space is wasted. If the tree is fully populated, then it is okay. But if the tree is sparsely populated, in those cases we can use a map. During the insert operation, when there is no entry for the current character in the child pointer map, then we add an entry. For example, when we start, we try to insert the letter B. Okay. At that time we check whether there is a pointer to a child node that represents the character B. So if there is no pointer exists, then we create a new node and update the pointer at index 1. Likewise, from here, when we try to insert the second character in the trie data structure, we check whether there is a pointer exists at index 0 that is corresponding to letter A. If there is no pointer, then we create a new node and update the child pointer at index 0 for this node. Okay, as each character is inserted, we check whether there is a pointer to a node corresponding to that character from that level. If there is no pointer, then we create a new node and insert it. And at the end, we setting up end of word boolean to true in this node. So in this case, the number of child pointers stored in each node is very less compared to the tree which uses the list to store the child pointers. So after inserting, when we search for a word, we start from the first character of the word, we go down the tree. Okay, for each character we check whether there is a child pointer exists for that character. If there is no pointer exists, then we return false because the input word doesn't exist in the tree. After processing all the characters, we have to check whether the node that represents the last character has the end of word boolean set to true. In that case, we can return true for the search operation. In the case of starts with prefix operation, we have to traverse the tree same way. For example, if we want to look for a word BA as the prefix, then we start from this node. First we check whether there is a pointer to node B in this node, and then we go here, and from here we check the next character whether there is a pointer exists for the character A. If it doesn't exist, then we return false. There is no word with the prefix BA. But in this case, there is a prefix. So after reaching here, we come out of the loop and return true, saying that there is a word bat that has the prefix BA. So that's what I have returned here. We are given a list of operations, so we process each operations in this loop. First we check whether the current operation is a trie operation. That means we have to initialize the trie object with the root node. Next, if the current operation is an insert operation, then we initialize the current pointer to point to the root of the trie, and then traverse the characters in the input string. And if there is no entry for the current character, only then we have to create a new node for that character. Otherwise, we can use the existing node and update the node pointer to point to the child node associated with the current character. Okay. Then we update the current pointer to point to the next level, and we repeat this process until all the characters in the input string is traversed. After we come out of the loop, we have to mark the end of word flag to true in the last node. Next, the search operation. So here also first we initialize the current pointer to point to the root node. Then we traverse the characters in the input string. If there is no entry for the current character in the node.children map, then we have to return false. We repeat this. After coming out of the loop, we check whether the last node's end of word flag is true. If that is true, then we return true. Otherwise, we have to return false. And in the case of starts with operation, here also first we initialize the current pointer to point to the root node and traverse each character in the input string. And if there is no entry for the current character in the children's map, then we have to return false. Otherwise, after coming out of the loop, we return true. Let's look at the flowchart. Input for this insert procedure is a pointer to a trie data structure and the input string word. Okay. First we initialize the current pointer and the count variable. The current pointer points to the root of the trie data structure, and the count is initialized with the length of the input word. Then we enter the for loop, and in each iteration we compute the ordinal number of the current character by subtracting a from the current character, and then we check whether there is a child pointer exists at the ordinal number in the children map of the current node. If the pointer doesn't exist, then we create a new node for that current character, add an entry to the children map with ordinal number as the key and the current node created as the value. Next, we update the current pointer to point to the child pointer located at the ordinal number. We repeat this process until we process all the characters in the input string. Then finally we come out of this for loop and then set true to the end of word flag of the current node. Next, we look at the flowchart for the search operation. Input for this procedure is the pointer to the trie data structure and the string word. First, we initialize the current pointer and the count variable and the count and return variable. The current pointer points to the root of the trie data structure, and the count is initialized with the length of the word, and the retval is initialized with false. Then we enter the for loop. Each iteration we compute the ordinal number of the current character by subtracting a from the current character. Then we check whether there is an entry for that ordinal number in the children map. If there is no entry exists, that means the word is not present. Then we return false. We set false to the return variable. Otherwise, we update the current pointer with the pointer to the children located at the ordinal number. We repeat this until we process all the characters in the input string. Then we come out, and finally we check whether the end of word flag is set to true for the last node. If that is true, then we set the return value to true. Then finally we return the retval variable. Next, let's look at the flowchart for this. Starts with procedure. So the input for this procedure is the pointer to the trie data structure and the string prefix. Okay. First, we initialize the current pointer and then the count and retval variables. The current is pointing to the root of the trie data structure. We initialize the count with the length of the prefix, and then the retval is initialized with false. And in this for loop, each iteration we compute the ordinal number by subtracting a from the current character and check whether there is an entry in the children map for the ordinal number. If there is no entry, then we return false. Otherwise, we update the current pointer with the child pointer located at the ordinal number in the children map. We repeat this until we process all the characters in the prefix, and finally we return the retval. Let's move on to coding. First, I define the node structure, which has two fields. One is the end of word boolean, and the other one is pointer to the children, which is of type map of byte to pointer to a node. Next, I define the trie structure, which has one field, root of that trie of type pointer to a node. And next, I implement the constructor function for the trie. First, I create a node with end of word flag to false and empty map of byte to pointer to a node. Then I set that as the root node of the trie and return the trie object. Next, I'm going to implement the insert function. First, I define the current and node pointer. Next, I define the boolean OK, and then the variable count which is initialized with the length of the input word. Next, I initialize the current pointer to point to the root of the trie. Then I write the for loop to process all the characters in the input string. Each iteration, I compute the ordinal number for the current character by subtracting a from it. Then I look up the children map and check whether there is an entry for the ordinal number. If there is no entry, then I create a new node. Then I add that node as a value for an entry with the ordinal number as the key. Then I update the current pointer to point to the child node that is associated with the current character. Once all the characters are processed, then at the end I mark end of word flag in the node associated with the last character. Next, I am going to implement the search method. First, I initialize the current pointer, current and node pointer, and then initialize the boolean OK to false. Then I initialize the count variable with the length of the input word. Next, I initialize the current pointer to point to the root of the trie structure, and then in the for loop, I process all the characters in the input string. Each iteration, I compute the ordinal number by subtracting the letter A from the current character. Then I check whether there is an entry for that character in the children map. If there is no entry, then I return false. Otherwise, I update the current pointer to point to the child node associated with that current character. After processing all the character, finally I check whether the last node has the end of word flag set to true. If that is true, then I return true. The word is present in the trie. Otherwise, I return false. Next, I'm going to implement the starts with method. First, I initialize the current and node pointer, and then initialize the OK boolean to false, and initialize the count with the length of the prefix. Next, I initialize the current pointer to point to the root of the trie structure, and then I process all the characters in the prefix in this for loop. Each time I compute the ordinal number by subtracting a from the current character. Then I check whether there is an entry for that ordinal number in the children map of the current node. If there is no node, then I return false. Otherwise, I update the current pointer to point to the node associated with the child. Then finally, I return the true. Next, I'm going to run the test cases.